The question, w equals this and z equals this. First of all, find wz. Let's find that first of all. So w times z is w times z. This is this multiplied 20, 5i, 12i, 3i squared. Now remember that I squared is minus 1. So this is minus 3. 20 minus 3 is 17 plus 79. So one thing is done, and the question says also again, and hence so that tan inverse 3 by 5 plus tan inverse 1 by 4 equals pi by 4. By considering arguments, we have to show that. Now the argument of a complex number is the angle made by the complex number, let's say this, and the x-axis. Let's do this. Look, here is 3 by 5. Look, 3 by 5. So, and 1 by 4, 1. So it seems that we need to find the arguments of these two so that we can prove this. First of all, draw a graph. This is a rough sketch. So x-axis, this is the real part, the imaginary part. Let's plot w, 5 plus 3i, 5 units across the real part along the real axis and 3 units along the vertical axis. So let's say this, and this is 3, and this is the complex number w. Okay, let's plot z. Z is 4 plus I, so 4 units along. This is 4, I say, this is 4, and 4 plus I is simply 1 unit here, so this is z. Okay, 5 plus 3i, 4 plus I, and wz, let's take about 17. So okay, here's 17 somewhere, 17i up there, so it may be something like this. It may be, we don't know. Actually, we don't need to do this, but it will give you a rough idea. Now remember that when multiplying two complex numbers, their arguments will add up. That is to say, the argument of wz, okay, the angle made by wz and the horizontal axis is going to be equal to the argument of w plus the argument of z. If it were w by z, it would be minus. So wz would just go from this part here like this. Oh no. Since this is not an accurate sketch, I cannot tell, but we don't need that. Just it will give you a rough idea. So now, why did I draw this? Look, by considering arguments, it says, and we have considered the arguments. Now, what's the argument of w made by w and the x-axis? W is 5 plus 3i, so 5 plus 3i, the angle, okay, this is w, this is 5 plus 3i, the angle is, let's say, alpha equals what? Tan inverse 3 by 5, isn't it? Tan alpha is 3 by 5, therefore alpha is 3 by 5, tan inverse 3 by 5. The argument of w is tan inverse 3 by 5. It's simply the angle made by w and the x-axis, that's given by the inverse of tan. For z, it's 4 units here and 1 unit here. So this is angle tan alpha is equal 1 by 4. Alpha is tan inverse 1 by 4. So therefore argument of z is tan inverse 1 by 4. And what's argument of wz? Same thing. plot WZ. Okay, 17 units real, 17 units of parallel. So argument of WZ is tan inverse. Okay, let's say this is alpha. So tan alpha equals what? 17 by 17, 1. Alpha equals tan inverse 1. And tan inverse 1 is 45 degrees. But is radians and 45 degrees is pi by 4. Therefore, so haven't we proved by considering arguments, that is the argument of any two complex numbers multiplied will be the argument of the first plus argument of second. Argument of first found out, second found out, third is found out. It's tan inverse 1, that's pi by 4. Okay, I hope that helped somewhat. Thank you.